Okay, start recording. Okay, so we're going to continue with what we have done previously. Okay, so we already done with rule 32. Okay, rule 32 here, integration by parts. Now we continue with rule 33, separating variable and the rest. Okay, so over here, let's continue rule 33. Okay, separating variable. Okay, so you'll be given dy dx. This dy dx equations will be in the form of fx and gy. Okay, where x and gy, fx and gy actually times together. So our objective is to gather the x on one side, the g on the other side. So how we actually are going to arrange them? We're going to arrange them in this way: 1 over gy dy equals to fx dx. But the thing is, the the dy and the dx cannot be separated just like that by itself. So we have to put in the integration sign. So after integrated, okay, by using A, B, C, D, E, F, whatever the techniques that you need to do, okay, so by after separating, you have a result of y, gy, and your fx. Usually after integration, we'll have a plus c. Over here, we'll just put a single plus c on the either side. Okay, up to you whether you want to put the plus c on the left side or the right side. So as you can see from here, so this question, okay, separating variable, the question not going to tell you that you need to use A, B, C, D, or whatever the formula. Okay, maybe the question being nice, they give you some clue, but students themselves, they actually have to understand. They actually need to familiar with all the formulas and actually able to answer them independently. Okay, so from here, it's better to let students look at the questions. Okay, so let's see what are the questions that we have here. Okay. Oh, not enough space. Okay, let me put in the answer as well. Okay, so over here, we will see that there will be separating variable like this. So it's better for me to demonstrate how to actually do these kind of questions. Okay, maybe I do question 1E. Okay, I'll look at question 1E. So question 1E, we have x squared dy dx, x squared dy dx equals to y plus xy. So as I say, all the y have together on the same side, all the x have together on the same side. So first of all, I factor out y from here. So I have a 1 over y dy equals to 1 plus x over x squared dx. Okay, you will see that all the y term will be gathered on the same side, all the x term will be gathered on the same side. Then, okay, then after that, I separate them like this, 1 over x squared plus 1 over x dx. Then after that, I do integration. Okay, so again, you are reminded that these sections here will be up to students to do their own practice. Okay, to get used to the practice from previous exercises, and from now onwards, students need to recognize that the equation by themselves. So you have a ln of y equals to -1 over x plus ln x plus c. Okay, so since the question asks us to write in the form of y, a single y as a subject, so we have to arrange them accordingly. So I have a y equals to e power of -1 over x plus ln x plus c. Okay, so according to the indices rule, I have e of -1 over x, so times by e of ln x and times by e of c. Okay, so e of c is, since c is a number, e of c is just a number, a. So e of ln x according to the indices rule is x, then e of -1 over x as your answer. Okay, so your answer will be appear in this way. Okay, so students can actually look at the other questions, okay, to figure out how to actually do the exercises. Okay, so please try it out. Then after that, we have the remaining formulas, okay, applications. Let's go back to G, applications. So for your information, trapezium rule is no longer in the syllabus. It's fall under P2. So P3, they don't ask about this section. Then area formula. So we have the Cartesian form, okay, X and Y form. We have the parametric form. So this is just formulas. Again, what to integrate will be all rely on student familiarity with all the previous form. Area by Y, okay. So area by Y with the Y, okay. Then you have the parametric form. Volume by X, you have a pi with the Y square, okay, or the parametric form, or volume of the Y in the X square, or in the parametric form. Okay, students need to know how to do the parametric form. Then with the extra, so extra, 39 here is continue from your differentiation rule. Okay, remember the 2 power x formula. So this is the reverse process. And 40 is log of base a. Okay, so you have a ln over ln a, x ln x minus x plus c. This one extra is it serves as extra. It's not because of want to put it as a formula or what. It's simply because it appear from the past. It appear as part of the questions. Okay, so we want just to help students actually understand. Okay, there will be such questions actually appear before. Okay, then this is all for your integration formulas. So after you practice each of these exercises, then students will need to know, go back to the past year questions. Okay, when students doing past year questions, so please make sure you can look at the past year. Okay, past year questions from chapter 5 and chapter 5 integration. Okay, and chapter 7, which is differential equation. Okay, so from over here we actually cover for both. Okay, so until next time, so this is the chapter 5 and chapter 7 questions. Okay, maybe I will give you some idea about how does this chapter 7 questions look like. Okay, let's see. Let's try to look at some questions here. Okay, wait for a while. Differential equations. Okay, so usually differential equation, they will the question will be appear as a story. Okay, appear as a story. So students need to know how to actually read the story. Okay, so let's see. A temperature of quantity of a liquid at time t is theta. The liquid is cooling at the atmosphere, which temperature is constant and equal to A. The rate of decrease of theta is proportional to temperature difference, theta minus A. Thus, theta and T satisfy this differential equation. So this one here, they're already given to you. If the question being nice, they give this to you. If the question is not nice, then they ask you to form. the differential equation. Okay. So I find in any form the solution of this differential equation given theta equals to 4a, t equals to 0. So I have d theta over dt equals to negative k theta minus a. So we gather the form, okay, gather the same term together on the same side. So I have a 1 over theta minus a d theta equals to negative k dt, integrate. Okay, although that this doesn't look like the same y and x that we can usually recognize, but just make sure that this is a y, there's a t that appear there. Okay, so over here, through integration, you have ln of theta minus a equals to negative kt plus c. So by using the information given, it says that when t equals 0, theta equals 4a. So when t equals 0, theta equals to 4a. Let's put it in. Let's see what do we get. Ln of 4a minus a equals to 0 plus c. So c equals to ln of 3a here. So put the c in, ln of theta minus a equals to negative kt plus ln of 3a. So you have a ln of theta minus a over 3a equals to negative kt. Okay, so over here we apply our logarithm and log rule. Theta minus a over 3a equals to e of negative kt. Therefore, we have a theta equals to 3a e negative kt plus a as your answer. Okay, so this one is 5 marks. Then 2, given also theta equals to 3a when t equals to 1, show that k equals to this. So the second part, we need to find the value of k. So I have a theta equals to 3a e negative kt plus a. So from the information given here, so I have 3a equals to 3a e negative k plus a. So simplifying the form, so I will have a 2a equals to 3a e negative k. A cancels off, 2 over 3 equals to e negative k. So I have a negative k equals to ln of 2 over 3. K equals to negative of ln 2 over 3 from logarithm rule. Okay, we know that this is same as ln of 3 over 2. Okay, therefore this is right. Then after that, for part 3, okay, find theta in terms of a when t equals to 2. Express your answer in the simplest form. So let's try to continue. Then from here, I have a theta equals to 3a e negative kt plus a. Although that we already find the value of k, so I don't want to insert it in yet, okay, so that I can have a easier answer later. Okay, so when find the value of theta when t equals to 2, so 3a e negative ln of 3 over 2, and this is times by 2 plus a. So please understand that this question here is totally testing students on their logarithm skill. Okay, logarithm skill. So students will need to know how to do 3a. So this is e of ln 3 over 2 power of negative 2. Okay, plus a. So I have a 3a of e and ln cancel off. 3 over 2 power of negative 2 plus a. So power negative 2, so 3a of 4 over 9 plus a. Okay, simplify them. So you have a 4 over 3 plus 1. So you have a 7 over 3a as your answer. Okay, you have a 7 over 3a as your answer. So you can see that how this is differential equation questions will look like. Okay. Okay. After this, Okay, after you practice each of these formulas, then you can actually continue with the differential equation as I stated here for your partial questions. Okay, to get used to how to answering this type of question. Okay, I'm going to stop recording. Thank you very much.